This is Year 11 Homework 7 solution video. Typical quadratic, that is a U-shaped graph like that. Typical cubic goes up and back down like that. The 1 over x graph needs some axes actually. If I just draw them like this, it comes as an asymptote down there and just skims along and nearly touches the x-axis, and then it does the same underneath like that. So that's the typical 1 over x graph. Negative quadratic is just an upside down quadratic, a U-shaped, maybe a bit more curved than that actually, like that. And then this last graph is a circle. I'll just draw my axes, and it's got a centre of -2 plus 4, so it's actually got a centre about there. I'm just not using squares there, I'm just estimating where it is. It's got a radius of 4, and if it's 4 up, that means it must just actually sit on the x-axis there. So if I was to draw it in, it would go up and round like this. And that is not the best circle in the world. It's difficult to draw that on an iPad, but you get the idea. It is just sat on the x-axis. That is important. On to the next question. If I was going to write the equations of these circles out, it is x squared, this is the first one, plus y squared equals the radius squared. So that equals 4. When you tidy that up on this next one, I do have a centre that I need to worry about. So on question 2, it will be x minus 2 all squared plus y plus 5 all squared equals the radius squared. And something to note there, if I just make a point that that 2 becomes -2 in this bracket here, and that -5 becomes +5 in that bracket there. On to the next one. Again, swapping my signs around carefully, I will get x plus 6 all squared plus y plus 2 all squared equals the radius squared. That's there. On to the next question. I've got to swap the signs around on these again. Let me just... there isn't anything to worry about on the x, but this will have a -4 when I put it into brackets. And remember, I'm going to square this, so I'll have root 2 squared, which is 2. So let's actually see what that looks like. X squared plus, and then this is the y coordinate bit, y minus 4 squared, because it's positive here, you have a negative in your bracket, and then the radius squared on this side is actually going to be just 2. Root 2 squared is 2. That is it for that question. On to the next one. Now if I talk about these graphs that I've drawn here, I've got sine, cos and tan. I'll just highlight the key features. I'm going from 0 to 180, so 0 to 180 here, and it goes up to the 1 and then back down to 0 again on the y-axis. That's a sine curve. The cos graph for the same period of 0 to 180, 0 being here, 180 being here, it starts at 1 and goes through 0 and down to -1. The tan graph does something completely different. It's not even a continuous curve. There's this asymptote where x is 90 there, so that's a place where the graph never goes, and it starts at 0 and it goes up to infinity there, and then it starts at -infinity and then goes back up to 0. So that's the graph of tan x from 0 to 180. So that's what they look like. So on this next question, we have got to prove that 4 consecutive integers are even when you add them together. It does say sum there, I'm going to add them together. Now I'm going to use the integers n, and then the next one along would be n plus 1, the next one after that n plus 2, and the next one after that n plus 3. Now some have used n plus 1, n plus 2, n plus 3, and n plus 4, and you didn't have this one here that I've got, and that's fine, as long as you do the next bit the same as I do it, and you end up with 2 lots of something, you have solved the problem. So let's see what I'm talking about. Now I'm going to add them together because it tells me to. 4n plus 6. Now that, if you think about it, if you factorise it, is actually 2 lots of something. It's actually 2 lots of that. And what I've done there is I'm saying 2 lots of something. So these 4 consecutive integers add up to 2 lots of something. That must mean they're even, because 2 lots of something means even. So I could write, at the end, I could just write, therefore, even. Now some of you went one stage further and you wrote QED, which means, look, I've shown you what you've asked me to show you. It means I'm done, there you go, I've finished proving what you wanted. It might be nice to actually just have a little bit of text there to say, look, therefore it's even, I've shown you it's even. So that's a target for some of you actually, to make sure you do say, look, I've done what you've asked me to do. On to question 5. So on this question, I've got a circle and I've got a horizontal line, and it says to estimate where the two graphs intersect each other. So the first thing to do is to draw the graph. Now, without a ruler on this iPad that I'm drawing on, it is slightly awkward. That's not bad actually, but it's difficult to get a neat drawing. I'm not going to be getting a particularly neat circle either. There's not much I can do about this. Now the circle's got a radius of 3, so it actually curves up through 3. It goes through -3, back to 3 there, and then it connects like that. Now the line y equals 2 is a horizontal line that goes through where y is 2 like that. So those are my two graphs drawn, and it actually says where do they intersect, and if you think about it, they intersect here and here, and if you look on the grid, they're actually fairly easy to identify where those points are. This first one here is 2, 2, and this one is -2, 2, and that is only an estimate from the graph, but it is what it is. It says to estimate there. So I've got 2, 2 and -2, 2, and those are my answers to that question. Question 6 is a related question, which we'll see on the next page. Now question 6 says simultaneously solve, and it's actually the same two equations. So what you're basically doing is, instead of drawing the graph and estimating where those graphs meet each other, you are going to literally find the exact place where they meet each other. So that's the answer to this question at the bottom, where it says compare your answers and what's going on. Why are they similar? They're similar because on the first question you draw a graph and you are checking an estimate of where the graphs intersect. On this question you are actually literally finding the exact point where they intersect with each other. Let's see how you do that. Now you do that by substituting one equation into the other. Now sometimes this is an equation with x and y in it and it can be complicated. Other times, like this, it's more simple. Y is just 2, so I know that this is 2 here. So I can actually say x squared plus 2 squared equals 9. So I can just substitute in. So let's do that now. X squared plus 2 squared equals 9. So x squared plus 4 equals 9. So x squared equals 5. Now if x squared equals 5, we do have a problem for some of you in the class here. That means x is plus or minus root 5. And don't forget, on the last question, the graphs intersected each other in 2 different places. And those 2 different places are actually plus and minus root 5 on the x-axis. So if I go back onto my previous page, I said it was 2 from this sketch, but actually it's root 5 if you were to read down there, and this will be minus root 5, which is 2 and a bit. It's not actually 2, but that's only an estimate from there. Go back to my actual solution here. X is plus root 5 and minus root 5. And some of you weren't sure what y is, and that's funny because if you look here, y is 2. Y is 2. So actually you didn't need to do any calculations to work out what y was. So my final answer to this question, x is root 5, y is 2. X is minus root 5, y is 2. And that is it. The reason the questions are linked is because this is an actual calculation of where the graphs intersect. If we go back a page, this is just a picture where we're just trying to roughly work out where the two graphs cut through each other. And I'm sure you will appreciate this page is not very accurate. This page is exact. And actually, if I've written exact target in your book with T like that, T for target, and written the word exact, it's because you've rounded this off. And actually what you're supposed to do is possibly just leave it as root 5 just because it's more accurate. Well, that's it on this homework. You should really go back and fill in purple pen correcting all your mistakes and so on. That is how you're going to improve and get towards those grades 8 and 9 that we've been talking about in class. That's it.